Good morning, everybody. Uh, Here is our objective, and here's some paper chromatography, and here's some column chromatography. And this explanation will work for both of them, and also for gas chromatography and plate chromatography. We want to know what it does with molecules to separate them. Now, there's one really important term we're going to need to know, the word affinity. And we've seen it with like electron affinity before, and that's like judging how much it's actually energy that it gives off, but it's telling you how much the atoms want the electrons, how much they're drawn to them, because the more they're drawn to them, the more energy they give off. And you could think of affinity towards certain things. Like right now, my hands are kind of cold, so my affinity is towards like something warm. I've always been drawn to music personally, right? Now I want to look at this image to illustrate, to make an analogy with chromatography. Uh, it's a little pixelated, and when it zooms in, you may be able to see it a little bit better. Um, so you've got some bees, and you've got some hornets, and you've got some flowers. All right, bees, hornets, and flowers, and they are flying together at the start. All right, so there they are above the flowers. This is going to be an analogy for what happens in chromatography and why it happens. All right. Now, they're flying over these group of flowers. And you can see, you can maybe guessing that this is the stationary phase and this is the mobile phase. And as they move over the flowers, the bees are naturally drawn to the flowers because they like the pollen in them. All right. And you can see that the bees and the hornets are now starting to separate. All right. And there it's happening even more. Now, in this analogy, the bees and the hornets are the mobile phase. No, sorry, the bees and the hornets are the sample. The mobile phase is the wind that's carrying them along. You can't see it, all right? Just like you can't see the wind at your house. And the flowers are the stationary phase. And the reason that the bees get separated from the hornets is the bees have a natural affinity to the flowers, just like molecules are going to have a natural affinity to different solvents and to different stationary phases, or they'll have a lack of an affinity and then they won't travel as far. And that's basically how chromatography works. So this is what it looks like with chromatography, like in chromatography. You've got uh, a little beaker and you put your thing in and you wait some time, and the mobile phase goes up and it carries the solvent, no, the sample, sorry. And as you can notice, some of these compounds are slowly separating. I've got one here and one here. They have different affinities to both the mobile phase and the stationary phase. And that allows the molecules to separate, the compounds to separate, because they've got a different affinity towards the two phases of chromatography. All right. So here is how it works. All right. Now I've been using the word affinity, and affinity is kind of like an attraction. All right. All right. Now, here we go. So we have this sample and we run it through and you get this separation. All right. So what does this mean? What are things drawn to in this scenario? All right. Well, the square component has a high affinity towards the mobile phase. It traveled the furthest up on the stationary, on the column. All right. For this is modeling like a paper chromatography. Typically, liquid chromatographers run down, and uh, whereas the heart has got a moderate and so on and so forth. And the triangle, which was buried beneath this, has you could say that it's like basically insoluble in this mobile phase because it didn't move at all. All right. Now, the stationary phase in this scenario, the square had very little affinity towards it because it didn't stick with it. It went it went far, and in this scenario, our mobile phase or solvent probably went like up here somewhere. All right. So my paper had very no, sorry, my square had very little affinity to the stationary phase, whereas the heart had more because it didn't travel as far up. All right. And it's a mixture between the two. It's a lack of affinity to one or a drawing to other. There's a bit of a grayness, all right, with all of this in combination to each other with each other. All right. And the triangle you could say had a really high, all right, affinity. Now, so that's what that means in terms of the affinities of the various components that you're trying to separate to the stationary phase. Now, sometimes in chromatography, what might happen is you might have something like this, where you run your column and the solvent goes or the up there, but your whatever you're trying to separate gets clumped together. And the way to get around this poor separation of your components is to you want to vary the polarity of your mobile phase. You may make it more polar, you may make it less polar, but basically you just have to try things out until you can separate these molecules such that you're pleased with your results. All right. All right. Remember, chromatography works because it is oh, chromatography works because it's manipulating the intermolecular forces of molecules and their natural affinity to different things by making them stick or not stick or be carried or be not be carried. All right.